Hey guys, this is Coach Lowe, and this is Chapter 3, Section 3, the Angle Addition Postulate, Contextual Geometry. So go ahead and copy this down in your notes. You should have Postulate 3.1 and Postulate 3.2 already, and if you don't have those in your notes, then you need to grab a book next time you're in class and put those down. Postulate 3.3 is the Angle Addition Postulate, or the AA Postulate. For any angle PQR, if A is in the interior, meaning on the inside of angle PQR, we'll slide a little angle in there, then the measure of angle PQA plus the measure of angle AQR is equal to the measure of angle PQR. So if you'd like to draw a little picture of this, then let's draw that real quick. So we have the angle PQR here. So Q is the vertex, we know, because it's in the middle of that angle. So there's PQR. A is right in the middle. And the angle addition postulate says if A is on the interior, then that forms two angles, PQA and AQR. And when I add those two together, I get PQR. All right, the definition of an angle bisector. The bisector of an angle is the ray with its endpoints at the vertex of the angle extending into the interior of the angle. The bisector separates the angle into two angles of equal measure. So if this QA were in fact an angle bisector, the difference would be it would separate PQR into exactly two angles of exactly the same measure. This doesn't necessarily do that because they didn't tell us that QA, or that A, when I draw that line through it, or the ray through it, that it would be an angle bisector. All right, so if you want to draw a picture of this angle bisector, then we could draw, make it a little bit bigger here, and I'll show you what the symbols are. So let's say this is angle ABC. And a bisector will be a ray coming from the vertex that will split the given angle into two equal angles. So this is the notation for equal in measure. Sometimes they may just have a mark on it, just this little kind of part of a circle there that looks like that. That tells you that they're equal, or they may stick a line through it like that to show that those two are equal in measure. So BP, ray BP, would be a bisector of that angle, an angle bisector, which would make angle ABP congruent to, or equal in measure, the measure of angle ABP would be equal to the measure of angle PBC. All right, so that's angle bisector. If you need to pause the video or back up to write those down, please do so. All right, so let's work some problems knowing those two things. Let's see if we can figure these problems out. These three figures are obviously exactly the same figure, and they will go with the three problems to the left. We want to be able to mark them up, so I copied them 3 times for you. All right, if the measure of angle ABE, so let's go ahead and mark that. There's ABE, is 100. So the whole thing is 100 degrees, and ABF is 65 degrees. What's the measure of angle 2? So this is the measure of the angle that we need to know. Well, we know the angle addition postulate says the measure of angle ABF plus the measure of angle FBE, which is what we want to know, or angle 2, is equal to the measure of angle ABE. All right, so we have part of this. We know that ABF is 65. We don't know the measure of angle 2, and we know that ABE is 100. So we can say 100 minus 65 is equal to x, subtracting 65 from both sides of that equation. The other thing you can do is look at this and go, okay, this is kind of like the segment stuff that we've done before. Here's my angle ABE. I want to remove this piece from it to find out how much this piece is. So 100 minus 65 gives me that. So 100 minus 65 is 35. So the measure of angle 2 is 35 degrees. Woot woot. All right, next one. The measure, or find the measure of angle 3. So let's go over here and look. We want the measure of that angle. If FBD is 85, so let me go ahead and mark that. FBD, this whole angle, is 85 degrees. And FBE is 42 degrees. So let's mark this guy. FBE is 42. So now we have the whole thing is 85, or these two angles 2 and 3 together is 85. We know that the measure of angle 2, or FBE, is 42. Again, we need to subtract in order to find that missing angle. So 85 minus 42 is 43 degrees. So the measure of angle 3 is 43 degrees. If you had to set up an equation, we would say the big angle, angle FBD, is equal to, we'll say the measure of angle FBE plus the measure of angle EBD. Or you could say angle 2 and angle 3 if you wanted to, totally fine with me. So we know that this guy right here is 85. And this guy right here, angle 2, is 42, and we are looking for angle 3. That's a plus sign. We are looking for angle 3, so that's why we subtracted there. All right, if you need to back up and pause or whatever, then go ahead and do that. All right, let's move on to number 3. If the measure of angle FBD is 102, so there's FBD, so that's 102. And then it says BE bisects FBD, so let's go ahead and get BE here. If it's bisecting those, then we know that these two guys are equal in measure. Bisect means it's going to split into two equal angles. So we have two angles that are equal in measure. So whatever angle 2 is, that's also what angle 3 is. So it says find FBE, which is angle 2. Well, if these both are 102, then let's just split that bad boy in half. So 2 goes into 10 5 times. And then 2 goes into 2 1 time. So each one of those would be 51 degrees. 51 plus 51 is 102. So that checks. So the measure of angle FBE is 51 degrees. All right, good job. Let's keep going. All right, 4 more problems. All right, so now we have a different setup over here to the right. If WAZ is a right angle, so do you see WAZ is a right angle and YAZ is 35 degrees. I'm going to go ahead and copy these guys for you so that we can use them again and again and again. All right, so let's move these guys down here. So there's one, and there's another one, and here's the last one. Okay, all right, that way I can mark this up. All right, so WAZ is a right angle, so there it is. The measure of angle YAZ is 35. So what do you think you should do with this? If this is a right angle, which we know measures how much? That's right, 90 degrees. And then we have a piece of it right here that's 35. What is WAY? Well, WAY is part of that 90-degree angle. So if I do 90 minus 35, that will give me WAY. So 90 minus 35, I believe that should be 55 degrees. All right, so the measure of WAY is 55 degrees because 55 and 35 is 90, and that's what they said that whole thing was. All right, moving on to number 2. If the measure of WAY is 66 degrees, so this whole thing is 66, AX and AX bisect. So what does bisect mean again? Bisect means cuts it in two equal pieces. So AX bisects WAY, find XAY. So 66, these two right here add to be 66 degrees. So that means each of those has to be what? Half of 66. So 66 divided by 2 is 33 degrees. So XAY, and by the way, WAX also has to be 33 degrees. All right, moving on to number 3. Find the measure of YAO if the measure of WAO is 130 degrees and WAY, so this piece right here, is 70. All right, so the whole thing all the way around is 130, all the way over is 130, and this piece is 70. So we can see that 70 plus something gives me 130. 70 plus something gives me 130, or 130 minus 70 gives me WAY. Excuse me, YAO. WAY is 70. So we subtract those and we get 60 degrees. So YAO is 60 degrees. 60 plus 70, 130. Bam. All right, last problem. Find the measure of XAO. So this is what we're looking for. If, and let's label everything, XAY is 35, YAZ is 40, and ZAO is 42. So do you see that we just labeled every single angle that's on the interior that helps make up XAO? So we have 35 plus 40 plus 42. Everybody agree with that? Awesome. All right, so add all those together. So 5 plus 2 is 7. And then 4 and 4 is 8, plus 3 is 11. So the measure of XAO is 117 degrees. Good job today. Put a star in the top right corner of the first page of your notes and high five me tomorrow when you see me, or today if you end up watching the video today. High five when you see me in class, and we will get some points for you on those notes. All right, guys, talk to you later. This is Coach Lowe, and I'm out.